Hello, everyone. Welcome to the Active Inference live stream from the Active Inference Lab. It is Active Inference live stream 15.2 today, and it is February 9th, 2021. Welcome to the Active Inference Lab, everyone. We are an experiment in online team communication, learning, and practice related to active inference. You can find us on our website, Twitter, email, YouTube, Discord, or Keybase. This is a recorded and an archived live stream, so please provide us with feedback so that we can improve on our work. All backgrounds and perspectives are welcome here, and we will follow good video etiquette for live streams. Today, in the Active Inference live stream, you can check out the calendar for 2021 at this link on the left side. And we're here with the red arrow on February 9th for 15.2. This is our second group discussion with the two authors of an awesome paper about realism and computationalism and instrumentalism. And so this follow-up discussion, we're going to be probably taking it in a lot of different directions, bringing up some ideas that we heard about in earlier 15 discussions and sending us off with momentum into the future of 16 and beyond. In 15.2, we're going to go around and hear from everybody in the introduction section and the warm-up. And then we will jump around, go to some questions that we had from last week, and anything else that people are thinking about will be awesome to hear. So for the introduction and warm-up, I'm Daniel. I'm a postdoctoral researcher in California, and I will pass it first to Shannon.
Hey, I'm Shannon. I'm a PhD student at the University of California in Merced, and I'll pass it to Stephen.
Hello, I'm Stephen. I'm here in Toronto. I do a practice-based PhD, and I will pass it over to Dave.
Okay, I'm a retired IT guy with a background in process philosophy and natural language processing. Living in the Philippines.
And let's go to Ines.
Hi, everyone. So my name is Ines. I am based in the Berlin School of Mind and Brain, and I work in philosophy of cognition, and I'm very happy to be here. Thanks, Daniel. Pass it to Blue.
Morning, everyone. I'm Blue Knight. I am an independent research consultant based out of New Mexico, and I will pass it to Alex.
Thanks. Hi, everyone. I'm Alex. I'm in Moscow, Russia, and I'm a researcher in Systems Management School. And I pass it to Scott.
Hi, folks. I'm Scott David. I'm the director of the Information Risk Research Initiative at the University of Washington Applied Physics Lab. I've been a lawyer for 30 years, and we engineer legal and socio-technical systems together. Thanks. Is there anyone else to pass to? Daniel.
Thomas.
Oh, Thomas.
Hi everyone, my name is Thomas van S and I work in Antwerp on philosophy of cognition.
Cool. Well, this will be a really fun discussion. So let's just get warmed up with kind of the pivot point with the phase transition from all of our disparate lives, whatever we were thinking about before this conversation, and get warmed up into the paper. And so the three warm-up questions are on here. Anyone who raises their hand can just take a stab, and it'd be cool to hear from everyone. What is something you're excited about today? What is something you liked or remembered about the paper? And then what is something that you're wondering about or would like to have resolved by the end of today's discussion? So while people are raising their hand, one thing I was curious about is what leads one to be an instrumentalist or a realist? Like, how do we make that choice? What kind of sends us down one road or another, or is it something that's switched back and forth? Just something I was curious about. Anyone else have a thought on one of these warm-up questions, or just something that stayed with them from the paper? Dave, and then anyone else who raises their hand.
Yeah, I would hope that folks don't get stuck in having to choose between instrumentalism and really getting into the meat of causation in any particular topic that you're interested in. You gather data by looking at the envelope of a phenomenon, and when you've gotten enough data, you just say, well, what is it like to be one of them? And one hopes you've got enough mirroring or modeling of the relations that you can start coming up with some mirrored explanations of what is it like to be a thermostat.
Cool. Thanks. Anyone else? Stephen?
Yeah. Yeah, I think that this question around thinking about using an instrument is quite interesting, sort of that embodied sense of like, I'm probing something with an instrument as opposed to maybe using a tool, which maybe is a bit more like I can hold that in my hand. You know, I know what my tool does, but my instrument, there's like a little bit of a gap. So I like that way of thinking about how we are working with something between us and the world, and where does the idea of a system go in there, or where does the idea of a tool, or where does the idea of, you know, it actually in some ways is kind of realist in the sense of how we try and think about things physically. So I quite like that, ironically.
Shannon, and then anyone else?
Yeah, so I don't know what it's like to be a thermostat, but that made me think of the dynamics of a crowd that consists of a lot of individual people, and no one person in the crowd knows what it is like to be the whole crowd. And you can identify certain behavior that's happening at the level of the crowd, and we can be super instrumentalists and say this crowd is navigating a space or something. And that sits fine with me, but somehow when I transition to neurons in a brain, I want to say that there is something realist, and we don't have to be instrumentalist about the brain. We can say this population of neurons is representing some activity, but I don't want to say that about a crowd. But if you put those two side by side, I should have the same view against both of them.
Interesting. Thanks. Yeah, we line up all these kind of mappings, and then it's almost like, well, the linear regression is an instrumental way of doing statistics. So then if we're going to be serious about instrumentalism, could we replace linear regression with some other statistical technique, or does it come down to the details of the instrument? Ines, and then anyone else who raises their hand.
Yeah, I was thinking about Dave's remark, actually, which I also agree with. And I think that Dave's remark allows us to say a little bit more about why we need to be careful about being realist. And that is with the fact that if we're going to model, say, cognitive phenomenon, say, perceptual learning on something, or a phenomenon that is cognitive that entails also what it is like, then probably in modeling that cognitive phenomenon, we are going to have to take a very realist stance, because we won't be able to capture the what it is like. So in a way, if we are taking the realist path and saying that, well, my model is not only modeling the cognitive phenomenon, but actually that's how the phenomenon works by using these models and these representations, then we also are committed to the implication that that particular phenomenon does not have or is not permeated by any phenomenological aspects, because we are applying a reductionist model and taking a realist perspective. So taking a realist perspective is not going to be useful if we want to account for the phenomenology aspect of the cognitive phenomenon. Yeah.
Thanks for that. And anyone else can raise their hand. I have a question for the authors. So the title talks about computationalism, but one of the main tensions in the paper is about instrumentalism and realism. But the title has computationalism and realism. So what is the relationship between computationalism and instrumentalism? Yeah, Ines?
Yeah, so I can say something about that. So in computationalism, we can take either instrumentalism or realism, which is cool. It's fine. One way to think about this is that I can be completely in agreement with computational science and use all the apparatus and machinery that computation science has to offer at our disposal, and I can use that from an instrumentalist perspective. Now, the other way is being realist within computationalism. And I'm going to say that it's not only a tool that I use, this computational machinery, but it's also the way that, in this case, the target system, which is the brain or cognitive activity, works. So these are the two options of options that we have within the computationalism. The typical standpoint is to be a realist about it. That's the history of philosophy of mind, is to apply a realist attitude towards our scientific models of the brain or cognitive activity. So it's not only that I have a representation, or I'm developing a representation of what I think the brain is doing in generating this data that I have access to, but I also think that this representation is also in the brain. That's also how the brain works, by having these sort of representations permeated with all these cultural constructs that we have, like numbers, logics, Bayesian inference, concepts, and all of that is in the brain too.
Cool. Thanks, Thomas. And then anyone else?
Yeah. So I think that's exactly right. And last time it came up as well that it seems like only philosophers are worrying about this or making this distinction or anything. But the thing is that you see that in certain scientific projects as well. When people, I've heard anyway of a research project where people are trying to identify particular priors in the brain, are trying to find neural correlates of the priors in Bayesian probability distributions. That only makes sense, like the entire research project only makes sense if you think the brain is literally engaging in Bayesian inference. So it really matters in that sense also for many scientific projects, whether you take an instrumentalist or realist attitude.
Thanks. Yeah, I think it's something we can kind of tease out and return to, is what are the implications for where we fall out on this instrumentalism and realism continuum, or what are the consequences for different projects or for different kinds of explanations, predictions, models. Is it possible to use Bayesian statistics instrumentally on the brain and be totally neutral and talk about it like it's you can model it usefully as a computer or as doing Bayesian statistics, but then not take the realist turn and say that it is doing that? Or do those two tracks run so close to each other that maybe it's just a slip from one to the other? And what would be the consequences of that? So Stephen, and then anyone else.
Yeah, I'd be curious to know whether you've got the idea that when you are trying to probe the brain or try to understand it, then you take an instrumentalist perspective. I was wondering if there is like a level at which realism is sort of still seen to be there, like even if it's in a sense that can't be seen, i.e. the free energy principle, because it's a principle, and the idea of non-equilibrium steady states, or the fact that it's, you know, that you need the dynamics to be happening rather than it being a system that can be just snapshotted. Is that in principle form still coherent to have as like a relatively realist interpretation? It's just that doesn't necessarily mean that any of your models are realist, they're just instruments. Or is it not that? Is there something like that kind of interaction at a more foundational level?
Cool question. Thank you. Dave, and then anyone else.
Yeah, on that point, I would recommend you look at the Mark Solms lecture series from 2013 on the conscious ego. He is both a neuroscientist and a psychoanalyst. He is also currently collaborating with Carl Friston and is in like 2 weeks bringing out a book that integrates dream study, psychotherapy, and Bayesianism. SOLMS.
Cool. Any other thoughts on the introduction, or we can just start with some of these questions that we had raised as a group last week? So yeah, sounds good. We'll just kind of, I guess, walk through a couple of these questions. People can take it in any direction though, so there's not too much of a linear ordering here, but we'll just walk through them. So this first question, several people spoke to it last week, and it was related to conscious awareness and to self-modeling. So I was reminded of this with Stephen's question about instrument and tool. So like, do we have an I? Is there something that isn't, is the, maybe I'll pick a different word that's not, literally the same EYE or I, but let's just say like for tactile sensation. Is it that we have proprioception, or that we are proprioception, or do we make a model of proprioception, or are we agnostic on how it really is with proprioception, but we're just going to model it a certain way? There's a lot of directions that we can take this, but I think that the interesting question that was raised is, where does the self-awareness come from? And then is a self enacting these types of inference schemes, or is it as if they're enacting schemes? How do we think about that for ourselves? How do we think about that for other systems? Ines, and then Shan.
I think that one point at which we can start this conversation is by asking ourselves, what is modeling? What are the motivations for us to get around and construct a model of something? So I would say that we model things that we do not have a complete access to. We are somehow missing something about. We have an object of study, but somehow we are missing some part of it that is puzzling to us. And we don't have a direct access to it. It's almost like saying we don't have the true posterior. So we need to find it by coming up with theories and by thinking about what would make sense to explain that particular phenomenon that we are puzzled about. So I think this is important for this question of self-modeling, because then it raises the question of whether I have access to the self or not. Because if we think that however we answer this question is going to be very relevant to however we think this question. If we think that the self is something that is hidden away and we don't have a complete access to it, then we could perhaps think about that, there's motivation to model the self. How is a different question. If we think that, no, I have a direct access to anything to the self on a conscious level, I might not understand everything about myself or the self. But I do have a direct access, in which case, perhaps there is no motivation to model it. So yeah, I just think this is a nice way to start thinking about this.
Thanks, Shannon, and then Thomas.
I'm actually going to hold my comment till a little bit later.
All right, cool. Thomas?
Yeah. So I think two other very important questions here. I don't know, maybe there's another one. What is access? What do we mean with the conscious level? What is the self that we are supposed to be modeling or not modeling? I think that might be it. And this seems a little nitpicky and typically philosophical, I can imagine, but it really is very important that we get clear on these things, because some people will have a very narrow definition of what you have access to, which will very quickly kind of mean you will need to represent or model just about anything. Whereas if you have a broader definition of what we have access to, that's going to change the story completely. The same thing goes with the self. Some people have different varieties of the self. There's this sort of pre-reflexive self that is just sort of selfhood, some people call it, that you just have a feeling of being yourself and as an acting person. And there's a narrative self, that's sort of the story you make up about yourself, like what sort of person am I, et cetera, et cetera. Those are all going to be enormously important questions to answer before we can really talk about what self-modeling on the conscious level even is, I think.
Great points. It is very philosophical to take one question and just fractalize, ask sub-questions, but it's so true. It really does matter. If we think that we're going to explain some consciousness in one definition, then we might be off base. So I guess since these are big questions, what might the free energy principle or active inference do to help us resolve or at least approach these ideas? Shannon, and then it could be on that or anything else, and then anyone else.
Yeah, so coming up from what you said, do we have proprioception? Like, do we have a certain sensation, or are we that sensation? Are we proprioception? And Inez's question, like, what are the motivations for modeling? And we model if we're somehow missing the full picture. And this brings me to, like, in Jakob Hovey's book, Predictive Mind, right? The brain doesn't have access to the sensory environment. The brain has access to electrical firing. And so it's trying to model what in the environment could have caused, or what could have caused that certain pattern of electrical firing. And back to last week when we were talking about representations having some sort of truth conditions. If we do, electrically stimulate part of your somatosensory cortex, and then your conscious self model is that I feel a sensation of somebody touching my hand because you stimulated that part of my somatosensory cortex. So on the conscious self model level, I'm making sense of what my neurons are telling me, and my neurons, if we're asking what is it like to be a neuron, is making sense of the electrical signals that it's receiving by saying they must have come from this area of the body, because usually when these neurons are stimulated in that way, that corresponds to a sensation from the sensory environment from this part of the body. And if we think of it that way, then maybe we could say that set of neurons is predicting or doing some sort of modeling of the world, because it's using these signals as a stand-in for the world, these electrical signals as a stand-in for the part of the body that's usually associated with that. Or we could be instrumentalists about it and just say that we're using our math to describe that's how the neurons are doing.
Interesting and great to introduce that experimental result, that when you do, give a little electricity, the person will identify that as being experienced a certain way. So Inez, and then Stephen.
Okay, so I just wanted to address a few of Thomas's questions. And just to give a little bit of context with these particular questions coming from, I think it was from Mark's discussion with Mark last week. And we were talking about the body being modeling itself. And then these came up, what about self-modeling on the conscious level? What would that be? And here, I think that there are two things. So Thomas asked, what is I think I asked. Okay, doesn't matter. So modeling here is important because how is it that the self would be modeled is important, because all of us understand what is modeling from a scientific perspective, right? We develop our tools and we know how things are modeled, right? Depending on the target system, I'm going to use a certain set of tools that's going to be dictated by the system that I'm targeting. Okay, now we know what that kind of modeling is. I don't know what modeling is when we turn to the self. I've no idea what that looks like. Is it Bayesian inference? What kind of tools are we talking about that the nervous system or the body or even myself, and this is the point of this question, or even myself on a conscious level, and by conscious level, I don't even like the expression conscious level. Here I was more thinking of the agent level. So the agent that interacts with the world and has representations and thinks about the world, is capable of drawing, mapping things. That's a sort of a much more sophisticated kind of interaction with the world that entails language, concepts, logics, skills, and that's the agent level. Right, so this is like lifting up this conversation into the agent level and thinking about, okay, how is it that self-modeling would be motivated? Would it be motivated at all? And if it is, how is it that it happens? Because on an agent level, and I think this is a point that might elucidate things for us. On an agent level, is an agent ever engaging with Bayesian inference? I haven't learned Bayesian inference until very late in life. So before I learned Bayesian inference, I wasn't able to model myself, I guess. So that's the point. So even on an agent level, for me to interact with the world by using representations, because I can on an agent level, I don't think anyone has an issue with that, not even radical inactivism, not even any other inactivists, I don't think. So on a conscious level, on an agent level, where we can actually engage in representations and use logics and use our concepts, are we using these kind of modeling that we know what it is in science? So that's one point about modeling. The other one is, I think it was Shannon that mentioned this very nice example, and I think it's useful for us to look at, which is, Shannon said, I feel a sensation of someone touching, right? Touching my arm or something, right? So in that particular case, this is the agent level. That's why I think this is a nice example. In that particular case, I feel someone touching my arm. Do I go around and start wondering about whether I felt that touch or not? Because that would be starting off an inference kind of thinking, which we can totally do by using logics and deduction and induction and abduction, all of that. We can totally do that because we are enculturated beings. Now, do I wonder about whether someone did really touch my arm? Whether do I really feel pain? Because if I do wonder, then I engage in inference kind of thinking. But that also does not come for free, that I'm using Bayesian inference, unless I have the training and I'm applying that for that purpose, right? So what I think is problematic about that is that once we start thinking about whether someone really touched my arm in kind of like a wondering kind of way, it's because we are assuming that we don't have a direct access to that particular experience. Somehow that particular experience is hidden from us, so we need to infer whether it is really the case that I'm in pain, for example, right? So that puts us in another yet level of experience, which is like the position of a spectator. The spectator does not have direct access to whatever is going on. So it needs to infer what is the most, the best explanation for that particular case. Yeah, I just wanted to add that.
Interesting. Thank you, Stephen, and then Blip.
Yeah, that idea of how much you have access to, and that may relate to different types of engagement, but the way, do we have access to our multi-sensory integration? So we have a sense that we are, like, I'm here now, I feel myself sitting, I can see, I can hear, I'm aware of stuff, and then I'm weighting that in different ways, just in my awareness, I suppose. And then there's the question of like what I actually choose to do, which may be more deductive, maybe more based on cues. So it is interesting once you get to this conscious level, is how much does the conscious level give us a way to not have to follow ergodic kind of flows, and we can kind of break out from that. But when you get down to lower levels, it kind of needs to be more flow. It needs to basically be more biological, so to speak. I don't know if that makes sense, but.
Thanks, Stephen. Lou?
So I just wonder, is the model of the self maybe the ego? Like, are those two things the same? And like, does the self model necessarily need to be like rooted in narrative? And I think we kind of touched on this a little bit last week. I think Scott had brought that up. And then just to reflect really on what Shannon said and what Ines just was talking about, you know, in terms of like a pain experience, right? Like this is kind of in like the Eastern traditions, pain is a very like objective experience. Like, yes, I'm feeling pain. Like I just burned my hand on a hot pot of water or whatever. So like pain is like an objective experience, but the suffering that's associated with that pain is a subjective experience. And that's part of like your ego or identity. Like, oh my God, I feel so horrible for myself, or like suffering in relation to the pain that you're experiencing is optional, right? It's not something that you have to necessarily like experience. And so I wonder then, is suffering like inference? Is that part that's the inference part, or I don't know, just a thought.
Yeah, it's like the observation, it's raining. And if you are, I'm the kind of person who's sad on a rainy day, or I'm the kind of person who's happy on a rainy day, it's quite disjoint from it raining or not. But then sometimes when it's biological and it's about our body, it's easy to conflate those two, like, well, pain is bad and it makes me suffer because it's painful. But actually there is a little bit of a step in between. Shannon?
Yeah, thanks for that. So yeah, I wonder if it makes sense to say to a philosopher that we have direct access to something emergent, but our brain is a spectator in this process. So I have access to knowing that someone touched my hand. I might question it if I see nobody's touching my hand, but someone stimulated my brain in a certain way, and I still feel that sensation. I still have direct access, I feel like, to that sensation. I don't feel like it's veridical with the world anymore, or veridical with touching on my actual hand. And then maybe on the level of the person, like Blue said, I can associate this feeling with pain, or if this is an instant where I enjoy this feeling, then I don't associate it with the suffering, you said, of pain. But my brain doesn't know that. Like, so my neurons are still being a spectator on these sensations and are still inferring something about their causes, or something about what the next sensation, the next pattern of activity will be given the pattern of activity they're feeling now. So on our side of these emergent processes, we can have something like direct access, but within all of the individual parts that make up that emergent process, we still have a bunch of spectators, a bunch of neurons.
Cool. Thomas, Stephen, Ines.
Yeah, so that's very interesting. Let's see. I initially had just a comment on Blue, but now also on Shannon. So I think the first thing to try and understand is what it really means to say that the brain knows anything at all. And that's actually something in Hoey's work that I would also quite strongly criticize, because there's a weird way in which a single organ in a body suddenly becomes an autonomous agent, where it is guessing things, where it is predicting things, it's knowing things, and doing all sorts of things that we would usually relegate to the personal level or the agent level. This is, I think, fairly well known among neuroscientists, the mereological fallacy, ascribing agent level behaviors to a part of the system. The thing is then that the brain doesn't have access and needs to predict, or because it doesn't know, doesn't really make any sense anymore when you just see the brain as an organ in an organism and the organism as a whole has access. So that's one point. The moment in what you're doing here basically is shifting from from a neurocentric way of doing cognitive science and definition of the mind to a more embodied one. And then if you're talking about the difference between pain and suffering that comes with it, as Blue was doing, under the inactive approach, the difference sort of falls away. And both of them are the very specific ways that the sensory stimuli and your own actions interrelate. Those are called sensory motor contingencies. So if you get a pinprick in your finger, the pain you're experiencing is the very specific way that the sensory stimuli in your finger change as you poke the needle in, or the needle gets poked in if it's not you doing it. Or it's about squeezing a sponge and the softness of the sponge. That's a very nice example. You only really feel the softness of the sponge as you're squeezing the sponge. There is no softness of the sponge separate from your squeezing. If you're not squeezing the sponge, you won't know if it's soft and you can't feel softness. So the softness you're experiencing just is the particular way that your sensory stimuli in your hand interrelate with your own squeezing. So there's nothing over and above that interactivity or underneath that interactivity that makes up the experience.
Interesting. Thanks. Stephen, Ines, Blue.
Thanks, Thomas. That's really well put. I mean, I think that's where the idea of the spectator, that in itself is you can fall into that trap of it being a part, because like a spectator is assuming like I see the story coming at me, and therefore the brain is having all this information come in, whereas if it's part of the mind is part of the body and the proprioception and the dynamic with whatever is being encountered, then that spectator role doesn't really make as much sense. So, and I think that that also then comes in with the active inference idea that the signal isn't coming in with the knowledge, it's being created somehow, well, through active inference, through this dynamical process. So I think that's really interesting. And one thing that's quite interesting to say with pain is pain. You can only create pain through. You can only talk about pain through metaphor. It's a stabbing pain. It's an ache. It's kind of a burning feeling. So all pain is expressed or has to be expressed through some sort of metaphor. So we have to utilize not just our proprioception, but we need to come back full loop with our sensory apparatus to create the thoughts. And this is where the mental space psychology work could be quite interesting to mix with that, because that idea there is that there's an organizing principle in the space around us, that we're effectively designing a mental space around us, which then becomes a part of that interface. So anyway, that's definitely an important point.
Thanks, Ines.
Okay, I wanted to just go back to the brain level, and then I want to go back to the self-modeling, just to make a point about that. So on the case of the neuronal level, I think that we were talking about the spectator, and we're trying to pursue this path where we were motivating why the brain is a spectator. And then Thomas made this nice comment coming from the reasons that Jakob Hui provides to that direction. And I just want to address that from the free energy principle and the active inference trend. So I think that even if we would accept that we were under the assumption and would accept the assumption that the brain is a spectator, and we were sort of agreeing here with Jakob Hui that the brain is encapsulated in the skull, therefore it needs to infer whatever is going on outside, we have to understand that the brain has not gone to school to learn Bayesian inference or dynamical modeling. So that's important. And we also should not forget, because this is what brings us all here. We're talking about free energy principle, active inference, and those things. So this is not something that active inference or the free energy principle will endorse, right? That the brain is encapsulated. According to the free energy principle or active inference, the brain is embedded in a multi-scaled system that many people call can be captured by nested Markov blinkets, yada yada. So this multi-scaled system itself organizes at every single level and in function of immediate influences that we can explain, for example, by applying active inference and Bayesian and update belief and that kind of thing that we all know. So this means one important thing, which is that every part of the brain is interacting. Okay, and where there is interaction, there is no spectator. There are these causal influences, and this is the principles of effective connectivity, for example, which we talked about last week. So I just wanted to put this out there that this sort of like spectator encapsulation is something that would not be endorsed. And I think that this is the right way to think. I'm just not sure if we should take the realist view about it. The other point that I wanted to make, just going back to the self-modeling, and then probably we'll just drop it, but I think that this is important for us to think, and it wasn't mentioned. The self-modeling, it's important to ask, who is doing the modeling? In self-modeling, who is doing the modeling? Is it a homunculus? So I think this is important because there have been a few arguments against this idea of self-modeling, and it's important to know who is, because in science we know who's doing the modeling is the scientist. In self-modeling, I'm not sure who's doing the modeling. Yeah, and yeah, these were my points.
Thanks a lot, Blue. And then I'll ask a question from the live chat.
So I don't know, the brain as a spectator is an interesting point, and also like who is doing the modeling. Like these two maybe might go together, but maybe are encompassed by a bigger question. Like what does the brain know versus like what does the mind know? And are these two things interchangeable? Like, and what does the free energy principle apply to? Does it apply only to the brain, or can we scale it to maybe include the mind, right? Or maybe the brain is part of the mind if you take a more embodied approach, or what is the mind has also been like posited to be maybe like the bioelectric field that's been out there in some work. So what is the brain? What is the mind? Is the brain part of the mind? I would say a pretty large part. If you're looking even at the bioelectric field, it's a big part, right? Like, so the brain has most bioelectric activity, so maybe it scales to that. So and maybe like the integration of all of the systems happens outside of the brain. I mean, maybe a component happens inside the brain, but maybe then it scales up to include like embodied knowledge, such as, you know, the gut-brain axis or other areas. So I just was wondering really what the free energy principle as developed by Friston, I guess, is that a brain specific, or what do you guys think? Can it scale to include the mind, or are these the same thing? I don't know, just curious.
Yep. I'm gonna just wait for the live chat because it looks like a lot of people have thoughts on Blue's question. So Stephen, Ines, Thomas, and then I'll ask a question.
I mean, this is also where the free energy principle and the active inference side comes in. So I suppose there's the active inference would be, like you could say, it has to be an active. So it's the whole mind, body, environment dynamic. But then the question with the brain is there a level of the brain? This could say it's all using free energy principle, but maybe there's a level of the brain which is, using free energy principle approaches to create the consciousness as this kind of epiphenomenon that's sitting on top of the whole organism, which is more broadly using active inference with the senses. My feeling is everything has to go back to the mind, body, environment at some level, but there may be some, I don't know, some like slightly higher level encapsulated piece that gives you the ability to have this reflective capacity of consciousness at like the human level, but I'm not sure.
Thanks, Stephen. Ines and Thomas.
Okay. So I just wanted to address the mind-brain, whether the free energy principle applies only to mind or brain or both or only that. I just wanted to bring to the discussion the fact that the free energy principle is a principle that is supposed to apply to every single system that is in non-equilibrium steady states. And this is the majority of the world. It's very hard for us to find a system, a natural system that is not that is in equilibrium. So that's what the free energy applies to. Another way to say it is that free energy applies to anything that has a Markov blanket, in the sense that it's coupled with the environment, exchanging energy with the environment and interacting with the environment in that particular sense. Obviously, these things become much more complex to explain for us when we come to adaptive systems, because the levels of complexity sort of explode because of the higher levels of degrees of freedom, right? So just to put it out there, it applies to every single system that is in non-equilibrium, which is the majority of the things. And then we can pursue a sort of a line of research that is about the mind-brain identity, where we ask questions of whether it applies only to the mind, also applies to the brain, or applies to both of them, or tries to unify both of them in a single explanation, right? So I think that the machinery of the free energy principle with the corollary active inference is very nice to help us understand both the mind and the brain. And here by mind, I'm thinking about the agent level, where we can think about decision making, beliefs, what is motivating my actions in terms of more intellectual aspects of ways that I can interact with the environment, like having thoughts and beliefs. That would be the mind, and that would be the nice way where I think that the free energy principle with active inference can be very helpful to develop generative models for us to understand the specific psychological phenomenon that is on the agent level. And then we can also apply this machinery, these generative models to the brain level, which would be the neuronal level, where we will look at the connectivity in brain activity. And obviously, we can explain these things by saying that the activity in the brain can be described as if there was belief update, as we know with active inference. What I would then be a little bit more careful about is to say that this is precisely how neuronal activity or even the agent level works when doing its own reasoning to act in the environment. So that's what I would be a little bit more careful about, is then the second step. And I don't think that we lose a lot. I don't think that we lose the explanatory power, as long as we understand that this is a tool.
Thanks a lot. Thomas?
Yeah, I was basically going to say sort of the same thing as Ines did. I mean, that makes it a little easier for me. I think just mostly what I would like to add is the free energy principle isn't going to tell you where the mind starts and where it ends. Since it does apply to just about anything that exists. You can just take any system, draw your own boundaries, and start analyzing, and things will start popping up. When you want to think about where is the mind, is it the body? Is it the body in an environment? Is it just the brain? Those are philosophical questions that will need philosophical answers. You can answer that in different ways, and if you want to say it's just the brain, you're going to end up in sort of Howey's camp, the predictive mind. If you want to say it's the body in its environment, you're going to end up more in an inactive camp. But those are separate questions that I don't think you're going to answer just by looking at the formalism.
Cool. It's like, should the title of your book be The Predictive Mind, The Predictive Brain, The Predictive Brain Body Mind, The Predictive Niche? You could keep going. And the point is, when we're taking this instrumentalist, multi-scale, nested Markov blanket approach, you just could kind of pick your title depending on what you want to emphasize. So the question from the chat, which I think was related to this question about who is doing the self-modeling and who am I, which sounded a lot like some meditation prompts. The question from CB in the chat was, can spontaneously arising thought give us insight into answer the questions in this discussion that cannot be given by any other research or other thought types? If yes, where and how? Thanks a lot. So as selves, if we're thinking about this self-modeling at the conscious level, Thomas, you just said maybe there's things the formalism isn't going to resolve for us. There's uncertainties we have that aren't going to be equations resolving it for us. Might spontaneously arising thought or other types of reflection maybe shine some light into any of these questions? So I'll just put that out there and go to just leave it up while we go to another slide. And then Stephen, just to put this up, because this was some related questions about the body's expectations and about where these priors or these expectations come from. So any thoughts on the spontaneously arising thought or any other topic? Stephen, and then any other hands.
I think this is quite interesting from the point of view of how neurophenomenology is generally done with people doing meditation. So there's the idea that, you know, you track your thoughts that come up and then you sort of capture them. But the question is, well, what's going on when I'm in the flow? What's going on in my pre-reflective state when I'm in action and interaction? A bit like now, where in many ways that's what most of my life is, and most people's life is, and actually where maybe a lot of the interest is, because that's where we struggle or have opportunities. So I think this question about how are we when we're in this other sort of dynamic, and how can we go back and revisit or explore what it is to be in action and what's going on there. So I think that these same questions sort of feed back into that.
Related to the flow state and what it means to be a self, are we most in touch with ourself? Are we accessing ourself, being ourself most when we're writing a personal statement, or when we're really focused on, you know, downhill skiing or a chess game, the kinds of things that Suzette Mahali wrote about in Flow? And so during the downhill skiing or the chess game, maybe somebody is not thinking about some of their somatosensory or their narrative self. There's aspects of self that are actually specifically turned down to like almost zero. And then there's a different focus, but then maybe somebody might self-report after the skiing, I'm so happy, that's when I feel like myself. And so what is this self that we're getting in touch with, and how is that related to our spontaneously arising thoughts? Blue, and then anyone else.
So just to kind of comment on that and then tie it back into what is the self that's doing the modeling, right? So the flow state is super interesting, and it's like that is the space where the ego kind of drops away, right? Like when you're in downhill skiing, like you're not thinking about like what my colleagues thought about what I said at the business meeting. Like it's totally not at all in your like mental, like all you're doing is focused on that task. And especially in kinesthetic like situations, like dance and drumming and all of these things, which also tend to like alleviate the trauma experience, right? Like, so all these like where the flow state happens, that's where there's really not that ego. So there's not that like self doing the modeling, but then the ego might go back and be like, I'm an awesome downhill skier, right? Like, so there's this, right, like self-reflection on the flow state that is that the integrator, right? So it just kind of maybe gives more like rise to the ego doing the narrative or the modeling when you're doing that self modeling or self narration, right?
Yep, really interesting. I'll throw another question from Marco in the chat. Marco wrote, how about taking mutual inference more seriously and posit that mutualistic interactions are legitimate processual entities which may possess the potential to realize a Markov blanket in turn? What is the maximum Markov blanket? Like I noted last session, I don't think that the XOR, so kind of the logical Boolean gate attitude to the schema and categories of realist instrumentalist, basically, I can't read it live, but yeah, like should we be looking for a disjointness between realism and instrumentalism? That's kind of the topic of this paper. So how do we take a realist approach to the instrumentalists? Is almost what Marco is getting at there. But anyone can take a thought on that. Thomas and then Ines.
I was mostly going to ask, where is the chat? Like where could I perhaps read this myself to try and sort out what exactly is...
It's the YouTube live chat. So if you just go to our Twitter, look at the most recent post, you'll find the link to there. But I'm not going to put it in the Jitsi chat here because it will make like a swoosh sound. But just go to the YouTube link from our Twitter.
Yeah.
Thank you. Ines?
I just want to sort of like address that by sort of throwing a question at it, or sort of a comment, actually. I want to say that, again, in that regard, I want to just point out that we, the neuroscientists, are the only ones who have the cake and want to eat the cake. And that means that amongst every scientist that is working with models across the world, in every single science, we neuroscientists are the only ones that are realists.
Very nice. And I'm going to take that to this next question. So as I understand that, it's almost like there's the Venn diagram of people who are studying models or using models. And basically, no one has a problem with, oh yeah, the flow of water through this dam is going to be modeled with this kind of an oscillator. Everyone's pretty instrumental about, and then you have people who are thinking about the brain. And there, it's kind of like the stakes are high because it's us on the table dissecting ourselves. And so it's hard to step away from a realist interpretation from what's, right inside. So how do we step outside of that? And then this is where I put with Alex's suggestions and prodding about where engineering fits into this. And almost is engineering like radical instrumentalism when we're dispensing with any kind of realism and we just want to get it done within the time frame and the budget and the affordances that we have? Is that akin to engineering? So Blue, Stephen, and then anyone else.
So I love that neuroscientists have their cake and want to eat it also. And I just was like thinking and reflecting, like maybe there are actually some other groups where that applies, like medical doctors, also like kinesthesiologists, right? So anybody that kind of studies like the brain or the body, like does it apply? Like they have the model, they're also using the model. Like maybe they're not modeling modeling the model like within the model. I don't know, like it's like it gets like very nested with neuroscience, but there maybe are some other groups that are doing this as well.
Great. Stephen?
I would actually question that because I'm having some challenges around working with complex adaptive system applications in other fields, like social development and stuff. And I think that they may be the only ones that try and get the cake and eat it. but everyone is just swimming in cake mix in a funny way, because everyone assumes you can make a system model, and that the system model can be a snapshot, and you have flows of real things flowing. It's very entity based, and even the idea of the self and the idea of the self, and there's a good paper on this by Bolis, and where he talks about the self is actually a social construct in itself. About 2,500 years ago, the idea of self was constructed, and I have a sense of self, so I'm in a society. And if you go back to indigenous approaches, you are one of the land. You and the land are one, which is maybe a bit more like reality, if we're going to say reality. But there is this challenge because everyone's using systems at some levels to make the models, or we talk about that way. So I kind of agree, but I would also say that it's there is a paradigm challenge here about how to think about what's going on in terms of how we are actually knowing about the world.
Thanks, Stephen. Blue, and then anyone else.
So that just reminded me, like the self as a social construct. It's a super interesting point. And I don't know if you guys are familiar with the work of Jay Garfield, but he talks a lot about the work of like the development of the self, like becoming self-aware or self-consciousness, like in terms of like a developmental aspect. And like you don't realize like the context that you realize that you are a self, like that's distinct. It's actually not yourself that you realize first. You actually realize others. So he talks about second person. So like you, as soon as you realize as an infant that there's a you who are going to come take care of me, like there's a you out there that are going to feed me. There's a you out there that are going to make me comfortable when I'm, sick or wet or whatever, like in very infanthood in the human species. As soon as we realize that there's a you, that's when the dichotomy appears that there's me, right? Like, so it's just very interesting because it starts as a social construct, this idea of the self from a very, very early age.
Thanks, Blue. And Alex, V?
Yeah, thanks. I want to add from engineering domain that for now, system engineering have a sad joke that we can't include people to the scope of the system because we can't control people. So we can control almost everything, but not people in the loop. So we are trying to go out of the way with it. But if engineering is a radical instrumentalism, we can consider active inference framework, which provides, as it was said, on agent level, some models which provide this opportunity to include people to the scope of the system, because and by organizing some communication structure around this agent and create some niche for them where we can communicate in some language of the domain we are working on. And here comes to the place all stuff with languages and with ontologies, and also for ontologies and knowledge lifecycle management. And it's if we consider it in engineering way and not trying to go down from agent level, but trying to see on agent environment, and maybe it's, as it was told, that we can say about agent level, how mind level, and for this mind level, the behavior of the agent is a correlate for his all kind of states under his Markov blanket.
Thanks, Alex. It's almost like because you can't engineer the human, you're engineering the inputs and the affordances. That's where active inference comes into play. It's like if you're going to do water engineering, you're talking about making the canal and the dams and the measurement devices, not going in there and engineering the water-water interactions. So engineering and instrumentalism is almost always at the periphery of an uncontrollable system interfacing between our regimes of order and attention, and then a system whose dynamics are being modeled instrumentally because it's the fringe. It's what's not known. So Ines and then Dave.
Yeah, I think that's about right, because we have a tendency to think that to take the realist approach, if we come from the sciences of the mind and brain, but then we would not commit the same kind of, or would not have the same kind of attitude if we were trying to model a non-adaptive system. So I think that comes from the fact that we do see that there's a difference between adaptive and non-adaptive systems, and that sort of like gives us part of the motivation to think that because they're adaptive, then they must be using the models that we are in order to explain them. But I think this is a fallacy that sort of conflates the explanando and explanatio. So, but the point that I wanted to make was more of coming back to the self as a social construct. We can push that even a little bit further if we go back to Maturana and Varela with the autopoiesis theory. And I find this very useful because it's a nice exercise. All of us take cognition to be something that is an ontological property of the organism. And this is precisely what Maturana specifically challenges with the autopoiesis theory. It tells us that cognition is a construct that is in the eye of the scientist. So cognition is not even something that has a referent in the world, which is super interesting because when we start deconstructing things like this, then this is going to have direct implications for the way we see models. What it tells us is that we observe behavior in systems as they interact, because they are adaptive systems. So they interact with the environment, and we observe certain behavior, and we make sense of it by coming up with patterns. That's how we make sense of this behavior. We come up with patterns, and then we deem these patterns or this behavior as cognitive. But we do this as scientists. The system itself, the organism itself, is not cognitive. This is not an ontological property of the system. So I think this is important to think about, because this also allows us to now, by taking the kind of same reasoning, then we can apply this by saying that we can model, we can observe this behavior, and we can pattern this behavior through the modeling techniques that we have. But the modeling technique is not an ontological property of the organism.
Thanks for that, Dave, and then anyone else.
If you want a real grasp of where a self comes from, you got to start with the newborn. Alan Shore did some very detailed work on the creation of the self as part of the mother-newborn dyad and the really intricate, not self-modeling, but us modeling, and a constant dialectic of alienation followed by reparation. You know, mommy disappoints the baby, and it's the worst thing in the world. The baby wants to kill mommy and then wants to eat mommy and wants to save mommy from the monsters. Well, once you got a good grasp of that, then you go and do ethological work and see how other creatures differentiate their children. There's a lot of socialization and a lot of creation of the style of a newborn colt, even though they can get up and run around pretty fast. And then you come back and look at pathological cases with humans. Melanie Klein was the first person who realized that you can psychoanalyze a child who cannot speak yet, and really worked at that and figured out how you can find out what's going on in the kid, who's the baby mad at, by seeing how he plays with toys, how he plays with dolls, his pictures. These kind of kids that can't speak can still draw and, you know, rip up pictures that they don't like. And there's a lot of poignance in the emergence of the self-creation of a self.
Cool. Well, to kind of operationalize that and bring it back to a figure and a question in the chat, this nested Markov blanket self concept, or in the neighborhood of the self. Someone writes in the chat, can we measure Markov blankets the way we measure or estimate any other physical entity? I've heard Carl Friston saying that every electron does have a Markov blanket. Can we measure, statistically speaking, electrons' Markov blanket? And I think it might be related to some other points that Marco has in the chat, which we can bring up afterwards. But it is really important if we're talking about Markov blankets, and that's figure 1, is this pink dashed line that is, and if that's how we're going to be modeling in the free energy principle, how do we do inference on these Markov blankets? What does have this, and how do we go from there? So Shannon and Ines.
Yeah, so this is a good question. We can, with a caveat, measure the Markov blanket of a certain electron or certain neuron. It's the statistical boundary here, and it's any states that you need to describe in order to explain the behavior of what you want to model. And you can kind of decide as a scientist at what level do you want to describe this behavior. So your electron's Markov blanket might not include the behavior of the body. It might just include the neighboring electrons next to it, or basically as far out as you need to explain the behavior at the level that you want to explain it. So it's not a fact of nature, which is me agreeing like wholeheartedly with this instrumentalist perspective. It's where you want to draw the boundary in order to explain the behavior that you're interested in.
Thanks, Shannon. Ines?
Yeah, that's precisely right. I wanted just to say that Markov blankets are not something that exists out there in the wild. So when we say that we can measure the Markov blanket of a neuron, I would probably just like formulate it differently. We can apply Markov blanket as a statistical tool to the level of description of a neuron, which is the one I'm interested. And it is precisely this special tool, this statistical tool, which does not have to correspond to physical boundaries of anything, because we get Markov blankets by identifying the influences that certain states have in another states. So that's how we find Markov blankets. They don't exist. They are a way of us to sort of like have a nice topology of how certain states are influencing other states. And in the end, we'd also get like a nice thing, which is like how a certain system is coupled with another system. And because of it's scale-free, as Shannon was rightly pointing out, because of the scale-free property of the Markov blankets, we can apply this statistical tool to whichever level of description we are interested in studying. So we can apply this to the single level neuron, but we can also apply this to a column, we can apply this to regions, we can apply to the brain as a whole, we can apply it to the organism that is coupled with the environment, and we can also apply this to social networks and things like that. As long as there are interactions and influences that are occurring between states, then we can apply this tool to explain how these influences are occurring between the states. And yes, this would be a very instrumentalist reading. And I think the only possible one.
Cool. And Marco adds a few more points and says, I don't buy the exclusionist categorization when it comes to FEP because it functions both as a modeling technique and an ontological system. And I think we're hopefully conveying what you're writing, and it's a discussion that is it's a yes and with realism and instrumentalism. And so I hope we're bringing a lot of perspectives to bear on maybe where the FEP sits in this space. And that's some of the great topics that were broached in the paper and some of the really important work that's being done so that we don't preemptively come hard on one side or have an exclusionist perspective. And part of that is actually enacting that conversation, not just having one really convincing thought that convinces us that it is way A or way B or neither A or B, but actually bringing together different perspectives on the topic and then seeing where that goes. So thanks everyone, as always, for participating, which is actually enacts the pluralism through participation. So Stephen and then Thomas.
We're kind of, one good thing about this paper, which is opening up even bigger aspects of complex adaptive systems applications. So I feel like we're putting a lot of bigger ideas on the edge of some other fields of practice on this work that neuroscientists is doing. But I think it's really valuable because there's this question of non-representational approaches in social sciences, which are kind of in that ways of trying to understand things around complexity has been used more. And one of the big areas by Michael Quinn Patton in qualitative research is there's this new work around principles focused evaluation, which moves away from more sort of betterment or sort of final product evaluation. This idea of looking at broad principles for projects which are evolving but haven't got a set of rules that can just be governed and replicated. It's formed, you know what it is. It's not completely being formed from nothing, but then you've got to work with the principles. And I think that may reflect some of this discussion that's going on here with rules and principles. Because I'm now thinking, well, rules are probably something that's more realist, and principles maybe are broader than that. I don't know. I think there's something around this broader area of complex adaptive systems in general and what it means to look at them. And then this is one aspect of that.
Awesome, Stephen. Thanks a lot. Thomas and Ines.
Yeah. So I wanted to quickly add on to what Shannon and Ines were saying in response to the measurement question. In full agreement, just to really answer the question, can you measure a Markov blanket in the same way that we can measure any other physical system? That would then be a no, because the Markov blanket is part of our toolkit with which we measure the system. And then on the Marco's comment on the exclusionary reading of realism and instrumentalism, and you either have to pick one or the other. That's a very interesting point, and I guess shows that the enumeration we had of different positions wasn't exhaustive. I had not personally really considered a pluralist account. And I'm not sure exactly what that means still, which is, I guess, part of why I didn't consider it. And I think that will really take some good spelling out of what pluralism really means here, because the only way I can think of it is different strands of realism. Because I don't feel like you can get any form of realism if you actually take instrumentalism seriously. In the sense that if you're saying, well, this is part of our scientific toolkit with which we're describing a system, realism is cut off right then and there. But of course, pluralism in the sense of let's discuss different ideas and look where that leads us is a different thing, and we should definitely do that, because otherwise, we're not really going anywhere. Yeah, that was
very, very interesting. It's like conversational pluralism or a social pluralism, exploratory pluralism is a slightly different kind of claim than the other sub questions that pluralism could impinge upon. Ines, and then anyone else who raised their hand.
Okay, so I wanted to address the question on the chat about whether we should be realist about free energy principle. And yeah, I want to just start by saying that the free energy principle is a principle. So we would expect it to have like something to say about a telos of things, some explanation that we would expect systems to behave in such a way. And this is what we discussed last week. There was a distinction between the free energy principle and process theories. Right, process theories aim to describe processes that would explain a certain psychological or cognitive or neuronal phenomenon or something like that. The free energy principle has something to say, teleologically speaking. So it has something to say about how we would expect an organism to behave towards something, some ultimate goal. Right, and this is, for example, that the system does not want to die, wants to avoid uncertain states because it doesn't want to die. So it wants to select the states that are going to be much more favorable to their existence in a particular situation. So obviously, the free energy principle has got these sort of like much more is charged with giving us an explanation about whichever we find the system doing, the system is going to be very likely is going to be evolving towards avoiding its dissipation. So that's what we get from, as opposed to the process theories, where we don't really get a telos. What we get is a description of processes in systems that minimize prediction error. But let's think about this and let's see what would be a realist take on the free energy principle, right? So the free energy principle is about systems or adaptive systems. It can also apply, as we said, to all natural systems, but let's take the adaptive systems here because they're much more complex and that's what we are interested on. So the free energy principle is about systems that minimize free energy expectation, right? Precisely because they want to do that. That's where we find the telos. So then I wanted just to draw attention to the fact that this explanation, this telos, applies to all adaptive systems. And that means that it applies to bacteria. And there's been also a paper with Friston and Calvo that it also applies to plants. And it also applies to systems with nervous systems, right? So a realist account of the free energy principle would say that every single adaptive system is minimizing free energy. That's a realist account of the free energy principle. Now, the question that follows is the one that relates to the paper that Thomas and I wrote, is, okay, so then are representations going to be entailed? In what level? The representations need nervous systems. Because the free energy principle applies to all adaptive systems, not only to the systems that have nervous systems. So if we take the realist path about the free energy principle as something that systems really do, they attempt to minimize this free energy, then this applies to all adaptive systems. So where does that leave us to the representationalist account?
Very thought-provoking. So maybe another way to say it, if I'm hearing it, is like, if it is the case that the brain, for example, is minimizing free energy, so that's the realist take on the free energy principle, then there have to be representations in the brain that correspond to free energy as being some sort of quantity that's being carried in the brain. Whereas to do instrumentalist free energy principle, one doesn't need to have any specific stance on whether representations of any kind exist, because it's being clarified that it's just like, well, the linear regression exists on my calculator, not in the brain. So yeah, is that, I hope related. Okay, Stephen, and then anyone else. And also, yeah, great points happening in the chat. There's a lot happening about, for example, natural kinds. Are they disjoint or are they isomorphic with Markov blankets? There's a lot of great points that people read and consider there. Stephen and anyone else.
I think one of the advantages the free energy principle has, and it's less clear once you start getting into the process theories, is if through this dynamical interplay between external states, internal states, and Markov blanket states, if it's working with entropy, entropy can be no dimensional. So you've got this advantage that it could be happening, and you could be inferring information by somehow extracting in whatever form somehow knowledge through a change in the randomness. So it's by a change in the randomness that you get a signal. There isn't actually a signal. You may not have that problem with representationalism coming up, even if free energy principle is actually kind of happening, because it's not clear how much it's become something with dimensions. So I think that the question then is, once you go beyond that into the process theory, maybe some parts of that as well are kind of dimensionless. There's still that flow, the nestedness, the nature of things traversed in between. And then there is the sense that once you create structures, that you do have physical structures and you get this realist, and you have to make a choice. So maybe, I don't know, that's just my thought on that.
And it's almost like, is the heart of the matter how something is or how we should act? Because if the heart of the matter is framed as being, I won't be satisfied till I get the realist explanation. I won't be satisfied with what an electron is until the heart of the matter has been reached, whether it is a particle, whether it is a field. And then if the heart of the matter were actually framed in an action-oriented way. So the heart of the matter is electrons. You could go way down the rabbit hole and sub-electronic stuff, but the heart of the matter is how we engage with electrons. The heart of the matter with a person is how we engage with them. In that case, it might be possible to have adequate, if not excellent, policy with a very partial instrumentalist reading. You could say, just with the models that we had in the 1980s, we had instrumentalist models of the electron that allowed us to build transistors of this power that were required for this task. So just taking the engineering take. And so again, by kind of making the heart of the issue about how to act rather than essence and identity, some of these questions that are related to representationalism, essentialism, internalism, reductionism, all of that is aligned with the heart of the issue being those topics. And so it's always a countervailing argument to take a relational or an interactive stance against that broader kind of philosophical gestalt versus the action-oriented turn, the pragmatic turn, engineering as a philosophy or as a way of life, and then thinking about organisms as more like engineers in their niche, like ecosystem engineers, niche modification. Evolution is selecting for good engineers, not the good philosopher, not the bird who thinks about how to classify the seasons, but the bird who reacts to the niche in a way that leads to continued success. So it's just very interesting, like almost a question arising is, we talked about these axes of variation, and this paper in figure 1 or table 1 laid out the 2x2. And so we can kind of lay them out orthogonally here, but there's a lot of these dimensions, and some combinations, 2-way combinations or 3-way combinations, might be very elucidating, considering, well, no one has thought about this combination of yes, 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 no, or which of these axes are kind of tied up axiomatically. That's pretty cool to think about. If anyone raises their hand, we can take it a different way. I'll just go through the final little slides that we had. So one slide says, where does design fit into all of this? Is design instrumental or realist? And what about technology? So we kind of talked about engineering, but what about design and all of its meanings? And then another branch we had explored a bit was, we kind of talked about it earlier today as well, is how can we really distill some of these claims? And so that could lay it out on a sort of shared table where we could come together with all of these different philosophical perspectives and experimentalist perspectives. How could we reduce this to a set of claims where someone says, actually, I disagree with claim 2, or I would like to add claim 3. And so that style of getting through these topics would be pretty cool. So with about, any amount of time that we want to have left, what's something that somebody would like to pick up on or head off in direction of? Ines, and then anyone else. Thanks.
Yeah, I can try to unpack a little bit claim number 2. So
Great.
I think that here, when we say that humans do inference, I think that's precisely right, but we can unpack this a little bit further. We can say that humans are capable in everyday life, because they are enculturated systems, they're able to engage in inference reasoning. They use logics and concepts, etc., that we already mentioned, right? So that's what we can do. But humans are also scientists, and they also receive training in modeling in general, so to speak. And once they do, scientists can also do other kinds of inference, which entail much more sophisticated kind of inference, such as all these tools that we've been talking about, like volitional Bayes and that kind of thing. So I think that it's important to say that in everyday life, we can engage in inference. That kind of inference does entail representational properties, because we are trying to build up a representation on the agent level about something that we puzzled about. And we can also do engage in this kind of inference as scientists with much more sophisticated kind of tools.
Cool. So anyone else have any thoughts on that, on this slide? Or let's just kind of give a quick another coat of paint on some of these topics, because a lot has been raised in this paper. I'd like to return to the roadmap and just think about what this paper did and ask the authors what their next ideas, just to any level of detail or however you want to convey it. What are your next exciting questions in this area, or how did finishing this paper prepare you for the next lines of research or investigation or collaboration that you're going to be involved in? Either Thomas or Ness, or anyone else. How's it going to change their research after reading this paper, actually?
I'll go first then. Well, hopefully I'll soon be finishing up my PhD, and even more hopefully starting a postdoc to actually be able to continue all of this properly. But I'm now working on a paper on anticipation. And in part, I am trying to put the free energy principle to use, and I'm having a look into how the notion of an information geometry can help us explain, formalize, or describe the sorts of statistical patterns that agents become sensitive to when they anticipate. So that's one of the lines that I'm hoping to make use of the free energy principle in an instrumentalist sense.
Cool. Thanks for phrasing it within the framing of the paper, I guess, Ines. And then we'll kind of move into the non-author collaborator range. Go ahead, Ines. Oh, sorry, you're muted.
Here we go. You can hear me now, yeah?
Yep.
Okay. So one exciting thing that Thomas and I are working on, and as a follow-up, together with another colleague, is precisely on how to move forward in cognition. What would this instrument would be put to a good use in understanding cognition, as taken models to be in a very instrumentalist kind of way. So what we want to say now is that moving forward, then models of cognition should not attempt to capture or represent the properties of cognition, of what cognition is, but instead the very idiosyncratic patterns of activity in a particular system. So what we are challenging is the representational models of cognition, that we don't think that makes sense, because for one, scientific work is not a perspective from nowhere, and for two, cognition is not a fixed structure in a closed system. So we take cognition in a very kind of dynamical system, stochastic system kind of way. So then we are trying to now develop the sort of like models that we think would be the most appropriate models to capture these aspects of cognition.
Sounds really interesting. I look forward to hearing about how you keep the general perspective while also diving into the minute particulars. Stephen, and then anyone else.
Yeah, I think it's helpful to hear this thinking about modeling, because trying to bring modeling into other contexts. So I'd be interested, like when Thomas there was talking about using information geometry and to think about how to model systems, and I think Ines is saying the same thing. Is it that you're not thinking about modeling the system so you can describe the realism of the brain, but it's like, how can you get the dynamics so it could be useful in, I don't know, computation psychiatry? Or it could, when you say system, you're trying to see how the dynamics reveal not necessarily a realist interpretation of the brain in the bigger system, but just something useful about the bigger system. Is it kind of like being more applied in some way to applications in the world? Or is that, I'll be curious on your thoughts on that.
Yeah, Ines.
So it's basically following exactly the same reasoning, which is coming from the view that we've come, which is that cognition is observed in behavior, in cognitive behavior, right? And we try to make sense of that. But cognition is not something that is static. It's something that is dynamic and evolves into a certain way because systems adapt, because systems have this particular feature. So what we think it's important to look at is precisely how can we explain these dynamics of this cognitive behavior instead of having models that aim to capture the properties of cognition in a very generalized kind of way, but much more specified into how can we explain this particular cognitive activity, and this can be applied in cognitive psychology labs, but it can also apply this particular way of thinking where models should capture these dynamics, and this is very much the dynamical system paradigm, where models try to capture the dynamics. Obviously, this entails a hypothesis and a theory about what we think is the best explanation for that particular behavior that we observed. And this could be like in, again, cognitive psychology labs, in perceptual learning paradigms, for example. But it can also be, as we spoke about last week, this can also apply to brain data analysis, because that's precisely what we don't know, is how the brain generates that kind of data. And then we can take different positions. We can look at mapping the structures, which is a very kind of like static kind of thing to do, because we want a topology, a nice topology of like the brain as a map, which is also very useful to have, but is very descriptive. So basically here we're dealing with description versus explanation, because once you have a model that is hypothesis driven, then you have a theory that you want to test. And that's what gets us into all the variational Bayes kind of area, and where you need those kind of tools, because we are working with a lot of theories and assumptions, and each model is precisely going to be a theory about what we think that perhaps has generated the data, which is what we actually have access to. So that's the kind of overview.
Here's one thought. Anyone else can raise their hand on actually where this philosophy to clinical applications comes into effect. So let's just say that there's some debate like about molecular reductionism that's unresolved in philosophy land, and then that percolates into the clinics before the philosophy is even clarified, like about genetic causation. So you have genetic counselors who are doing genetic medicine while there's still debates, what is a gene and what is causation? Should we think about genetic reductionism or holism? That uncertainty is actually in the research paradigm, in the comparability of results in the basic research, is going to lead to inaccuracy in communication and in confidence at the clinical level in the genetic case. Now, with FEP, we're kind of talking about neuroimaging in a big way. Also, other interoceptive modalities are being expanded, but really a lot of the foundation of this is in neuroimaging and neuroscience. And so if there is a mess philosophically, then the research is going to be less coherent, the communication is going to be less clear, it's going to lead to clinical inaccuracy. Whereas if it were the case that there was a clean philosophical way, at least to even frame the situation, perhaps that could lead to more interoperable research agendas driven by those who do and do not wish to engage in the philosophy specifically, and then increase clarity of like recommendation or of communication at the clinical level with people who are multiple steps away from the paper, but we could actually reference them this exact paper. For example, if someone said, we're hypothesizing that people who have this connectivity pattern in the dynamics of the SPM, it's not about how your brain's connected versus someone else, it's a hypothesis about a dynamical system. Just a thought. Ines, and then anyone else.
Yeah, I actually just wanted to read out loud a quote by Daniel Dennett that I think just really captures what you, Daniel, was saying, not only in the clinical setting, but also in particularly he's referring to science. And I think that, yeah, I very much agree. I think it's very insightful. He says in his book that, let me see if oh goodness, I lost it.
So you can take a second to find it.
Yes, yeah, I'll get back.
Anyone else can raise their hand in the live chat. People can provide any final thoughts or questions, but this is just really an awesome series. So I appreciate the authors for joining us both sessions, for all the participants who engaged with this paper, and we're already seeing how this debate is modifying the way we think about the topics. So Ines?
Oh yeah, I found the quote, and well, it tells us that the topic of representations should be. It tells us there's no such thing as philosophy-free science. There is only science whose philosophical baggage is taken on board without examination. And I think that really nicely captures what you were saying, Daniel.
Nice. Thanks a lot for sharing that. Shannon?
I think at the risk of bringing in a new topic with less than 15 minutes to talk, but this is a big question. So I don't know, in neuroscience, maybe there's this just pessimistic understanding that what the philosophers and neuroscientists say, once it trickles down to the public, it's going to be misconstrued. So we're just constantly reteaching the general public. And if a doctor is conversing with a patient, they're constantly saying, in this instance, this is the thing that's happening in your brain that matters for this diagnosis that we have to do to help you solve a problem or something. But at a moral and societal level, in every aspect of science, this debate between whether we're looking at a true natural kind or just something that we are taking a certain stance about as scientists, as a society, has huge implications for policy. I'm thinking of whether gender is real or not, and it has huge implications for policy that very detrimental, it hurts people. If you take a certain stance that there's a certain gene that codes for a gender, when that concept itself is a definition that might not be a complete scientific truth, but someone somewhere wants to say there's a scientific truth that gene means gender, means policy, means, and then you just have this cycle. So even though this seems like a very, maybe we could just say, I don't agree with the philosopher, or I don't agree with the neuroscience, and leave the debate. The fact that the debate exists permeates into the rest of society and culture, and it's important maybe to say that science maybe even as a whole isn't realist about the world. science is instrumentalist about the best way that we can interact in our world. And you do have to bring in that baggage that Daniel Dennett was discussing, and this would also include moral baggage.
Thanks, Shannon. And I posted this book in the chat, Studying Human Behavior, How Scientists Investigate Aggression and Sexuality by Professor Helen Longino. So taking a course with her in grad school and reading this book, the way that it framed pluralism and the sciences and the different methodologies, and just laid bare in some ways how these issues, it's kind of like having the cake and eating it too. It's like, these are the issues that are so near and dear to our social reality. And so it's hard to take the right stances philosophically when it's easy to lose sight of what's really happening sometimes and just how things are. And like, of course it's the Y chromosome. It's like, I mean, it's an allusion to genetic reductionism, but it's a little bit broader, or it's different than that. And it's a yes and with genetic and non, and it just goes so much beyond a simple reductionist claim that it's easy to get lost. So how can we even use active inference and the communication channels of public engagement to actually, at least within our subdomains or at informational niches at first, how can we bridge that gap in a new way is an interesting question. Stephen, and then anyone else.
Yeah, thanks for this excellent conversation. I suppose this question about whether we can not just take some realist neural correlation as our way in wasn't even an option before. It was like, it was basically, that was the only cake on the table. So people just took it, and now it's like, well, actually we've got this other way of thinking, you know. So the way we're doing it before isn't the only way. It's just, it was the only way. So I think that's one thing, and it's helping me because I'm seeing people in this area of mental space psychology trying to prove their field by saying, say, peripersonal space neurons are firing, and they're not necessarily, they're trying to use these brain processes as evidence, you know. And it's like, if you don't show causal, you know, and I mean, I even see that in my own thing. I think there's a tendency for me in my work with spatial approaches, how can I explain this? And it's like, and if you can't, what are you left with? You're just left with, well, not a lot sometimes. So this does give another way to make use of phenomenological wisdom, I think. So that's what I'm taking away from this. So thank you.
Yeah, thanks for connecting it to your work and experience. Blue and Thomas.
So I just wanted to thank Ines for that quote. I thought that was like really deep and important, and like a good understanding really of the philosophy that's like behind all of science might really enable us to go forward as a society. Like, I've just noticed with like COVID and like, at least in America and the stuff that's been going on in our country, like people are upset that the science is not right? Like what happens? Like the science, like they're very mad about like the science continually updating itself, which is kind of exactly what science is supposed to do. So I think maybe a good understanding of the integration with philosophy and, you know, the evolution of science as a thing, a non-equilibrium steady state that's continually being updated, like as a system. I think that might, you know, if it's pushed into like the mainstream, it might enable people to be more accepting of science when it changes.
Thomas, thanks a lot, Blue.
Yeah, I think it's very true that at least the way we see it now, if you start talking about questions like, is gender real or not, that it has very big impacts on policy and how we're going to change things. And I don't know, maybe this is a typical instrumentalist thing to say, but I wonder if it should matter as much. If it's not just we're seeing certain patterns of, say, injustice, and we need to address these patterns of injustice and try to create policies that remove that injustice, regardless of whether the categories that we use in describing the population that is affected by the injustice latches onto something real or not. I don't think that really matters that much. It's sort of the moment when you get into the philosophical debate about gender, when you're trying to discuss policy, I think you're doing policy making wrong. I think that you should be looking at what is going on. Is there injustice? In this case, we can say, yes, there is, and how can we tackle that? When you get into the philosophical debate, you're doing something else that's also important, but not for political policy making. And I think in some ways, I think Stephen said that about trying to legitimize certain parts of research by relating it to brain processes. Like, oh, the thing I'm doing is only really legitimate if I can point at the brain and say, like, these things are doing the thing I'm talking about. I think you see a similar thing with the neurodiversity groups, where people latch onto this scientific framework of, oh, well, autism is all in the brain, so it's real, so now you have to take me seriously. And I think that's, in some sense, it's nice to see that, you know, these things are being legitimized and people are taking it more seriously. In another sense, it's not good because we're restricting ourselves very much to a very particular idea of what counts as real, only if we find it in the brain. And as we've just been talking about, just looking at the brain, if you're trying to understand a broader picture of what an agent in an environment is doing, is very narrow. Yeah, that was it.
Great. Thanks so much for sharing that. I just wanted to kind of build a little bit on that. You said, like, whether we think X is real. There's so many issues: yesterday, today, tomorrow. Is X real? It becomes real when it has impact on policy. And what's so cool about active inference is we even use that term policy to talk about how things matter. And we use the instruments of these different models, the specific ones that we're talking about, to talk about how things bear upon policy. And so two of the things that active inference can help us do is, first off, it helps us separate our preference from our affordances, from the observations, from our policy. Because it's really easy when talking about things that really matter, climate change, all these other things, it gets quite blurred with what people's preferences as far as their short-term affordances, long-term teleos. And then also it gives us a forum and a shared understanding and vocabulary for actually having that realism instrumentalism debate. Blue, to what you said about this evolving state of science, developing state of science, you can veer off one side and say, well, it's real today, and what they say is real tomorrow. So maybe a realist stance lends itself towards kind of in-group thinking, because if you're being told, if the party tells you it's real today and the party tells you something new next year, you better be a realist about that, at least in terms of policy. Versus if we take a purely deconstructionist, it's all instrumentalist, then some people are going to say, wait, but if it's not real, like, I mean, are viruses real? We hope so. So what is real? And so that's the kind of questions that we can have a discussion that values people's perspective, modes of communication, modes of thinking, being different roles in complex adaptive systems together. So really awesome discussion. We're going to land it on time. But again, thanks everyone for participating. If you're listening, you're also welcome to participate in a future discussion or in any other activity of ActInf Lab, and just find us at activeinference.org and go from there. Ines and Thomas, we look forward to your future research and having you back for any conversations you'd ever like.